Hello and welcome back to Standard Quiz Review. This is Mr. Steele and we're going through the Term 3 Algebra 1 Standard Quiz at Franklin High School, and tonight we're going to tackle Standard number 4, the last one about exponents. And in fact, Standard number 4, as it says in my instructions right up here, is about simplifying exponents with expressions with exponents. Now earlier in some of these videos, in Standard number 5's video, we talked about taking a power to a power and the meaning of exponents themselves, and then in Standard 6 we talked about two specific cases, particularly the zero and the negative exponents. In this video we're going to talk about just general expressions with exponents. So we'll be using two of the first exponent rules that we taught during this year. So before I start there, I'd like to just start by reviewing those exponent rules and kind of talking about why they make sense and why they work. Because sometimes if you get stuck and you're not sure what the exponent rule is, you can go back and think about what exponents mean and get your answer. So the first one, it's always kind of written the same way. That's this, that if you have the base a taken to the m power times base a to the nth power, then you can simplify that by writing it as a to the m plus n power. Now again, I've already taught this, and you've already seen it a couple times probably this year as well as in the past few years in middle school. But at the same time, it still would be good to kind of look at it and think about what this means. So let's just look at a real simple example here before we get into real examples of the standard. Okay, so x to the fourth times x to the fifth. Well, if you remember, exponent expressions really have a specific meaning. So to help me do this, I'm going to use two different colored pens. So let's look at each of these individually. X to the fourth times x to the fifth. Okay, well, x to the fourth just means you're going to multiply x times itself 4 times. Right? No problem there. Okay. And then x to the fifth just means you're going to multiply x times itself. You guessed it, waiting 5 times. And so there we go. This represents our original problem, x to the fourth times x to the fifth. Well, if you look at this then, this is really just a whole bunch of x's. It's just a, just a whole line of them right there. So we can actually write this simplified as an exponent. In fact, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So this is x to the ninth. Well, lo and behold, if we'd used this exponent rule, we would have gotten the exact same thing. So in fact, the first exponent rule, this adding the exponents together when you're multiplying, actually ends up making a lot of sense. So there's one. Let's look at a second one before we do real examples. Okay, this one it's kind of the partner one. Instead of multiplying, this time we're dividing. And instead of adding, this time we're subtracting. So it says if you're dividing two things, same base, you can subtract the exponents and simplify the expression. So again, let's do one short example and think about why this actually works. Sometimes it really does help to see it. So we'll go x to the seventh over x to the fourth. So again, if we think about specific meanings here, x to the seventh just means x times itself 7 times. Should have picked smaller numbers, that would have saved me some writing. But hey, it's colorful. X to the fourth just means x times itself 4 times. And if we look at this, you might notice that we've got some x's on top and on the bottom, so we can actually simplify by making some ones. So x divided by x there will go there, there, and there. And once we've taken those guys out, we end up with no x's left over on the bottom, and on top x, x, x. So x to the third. And once again, if we were to have used our exponent rule, we would have gotten the exact same thing, because 7 minus 4 is 3. So there we have it. Two very valuable exponent rules that we're going to be using to perfection in standard number 4. Okay, let's get started then. Okay, with a little basic understanding of some of the important exponent rules kind of under our belts, let's go ahead and start and look at an example like what we'll actually see on the standard quiz. So this is the type of problem we might see if we're multiplying two expressions with exponents. So we've got the quantity 3 x to the fifth y to the seventh z squared times the quantity 5x squared y to the third z to the 100th power. Okay, so now over here, because the numbers were small, I was able to actually illustrate it all by kind of writing all of them out, but But if you kind of look at this, like, I would not want to write out z to the 100th power. Like, I'd probably run out of sharpies by that point, even though I actually have that many, well, and these. So, I'm not going to do that. What I'm going to do is I'm going to use the shorthand exponent rules. Before I do that, though, I'm going to actually try to keep all the, or get all the common factor or similar factors together. So let me just kind of write that down here. Okay, so let me show you what I actually mean by that. So what I'm going to do is I'm going to look at, first, before any of the other ones, I'm going to look at the numbers. So, got 3 and 5 there, and we're multiplying. So, 3 times 5 is basically what's happening here if we group those guys together. That's going to be 15. Okay, so we've taken care of that piece. Next, I'm going to look at x to the 5th and x squared. So we've got x to the 5th times x squared. And if we think about our exponent rules, we're going to be adding these guys because we're multiplying. So x to the 5th times x to the 2nd is going to be x to the 7th power. And so what I'm doing is I'm slowly coming down to my final answer. Okay, third, we've got y to the 7th and y to the 3rd. So again, we're adding the exponents here. It seems like we're probably always going to be doing these when we're multiplying. So y to the 7th times y to the 3rd, 7 plus 3 is 10. So y to the 10th. And lastly, the only other color I have left is black or purple, so hopefully this shows up. Last one, we've got z to the 2nd and z to the 100th. So z to the 2nd, z to the 100th. We're going to add these guys. 2 plus 100 is 102. So z to the 102nd power. And after all that work, we are actually at our final answer. That's really all it took. So there it is. Final answer, 15x to the 7th, y to the 10th, z to the 102nd power. Okay, so now I realize it's difficult when you're doing this sometimes because you're technically multiplying, but then you're adding the exponents. But if you just do it kind of slowly, like you actually do maybe one step of work like this, I think you'll be able to kind of reason it out, and you'll see that this is 15 and not make a mistake like writing that as 8. Okay, so that was one with two expressions being multiplied. Let's do one with division. So let's see how well I can actually make these up. So, let's go. Okay, here we go. Got one right here. Just made it up. Should be very similar to the ones you see on standard 4. This time we're dividing. So 8x to the 5th, y to the 13th, w squared, all over 12, x to the 2nd, y to the 20th, w squared. Okay, so what I'm going to do is I'm going to start simplifying this guy. And again, I'm going to do the same thing as before. I'm going to look at the similar factors together. So I'm going to look at first the numbers here, then I'll look at the x's, then the y's, then the w's. Okay, so first, for numbers, I'll use purple. 8 over 12, well, if we think about that, that's just a fraction. We can simplify it. Like 8 divided by 4, or 12 divided by 4, that's going to give me 2 over 3. So I've kind of simplified that fraction right away. Okay, next, x to the 5th over x squared. Well, x to the 5th over x squared, we're subtracting exponents, so this will be x to the 5 minus 2, which is x to the 3rd power. Okay, next one, y to the 13th over y to the 20th. That'll be y to the 13 minus 20. That's going to be y to the negative 7th. We'll deal with the negative exponent in just a second. For now, we're okay. Then last but not least, w to the 2nd, w to the 2nd. Well, you can already kind of see these guys just make 1s, so I'm not even going to bother with the 0 exponent. I'm just going to know that they make a 1. And so it looks like we're pretty close to our final answer. 2/3 x to the 3rd, y to the negative 7th. The problem is with that negative exponent, we're not supposed to actually have any negative exponents in our answer, so we just need to use our rule that we talked about in standard number 6 to simplify this guy. In particular, we've got 2x to the third over 3y to the 7th. If you don't believe me, what you could imagine is that if we drew out 13 y's up here and 20 down here, we'd end up with 13 of them going away and 7 being left in the bottom. So actually this answer makes a lot of sense. Yeah, it's maybe a little harder than standard 4, but I think it's a fair one to bring up. Okay, so there were our first two examples, one multiplying, one dividing. I'm going to go ahead and do a second example for each one. Alrighty, let's go ahead and look at this first example, or excuse me, the second example of the first type of problem that you might see on standard 4. So this time we've got negative 5, x to the 4th, y to the 5th, w to the 6th, times 10, x to the 3rd, y to the 3rd, w to the 5th. So again, we're multiplying, but either way we're going to try and work by grouping all the similar factors together and doing what we need to with them. So to start off with, I'll look at the numbers first. So negative 5 times negative 10. Well, negative 5 times negative 10 is going to be negative 50. So the numbers are out of the way. Second, let's look at the x's. So we've got x to the 4th times x to the 3rd. When you get x to the 4th times x to the 3rd, well, actually let's just go ahead and simplify it that way. I should probably be doing that. X to the 4th times x to the 3rd is going to give me x to the 7th. So let me go ahead and start a second line. I think this way is probably more helpful. Okay, so there's our second piece. Third one, y to the 5th, y to the 3rd. Well, again, if we add the exponents, 5 plus 3 is 8. So y to the 8th power. And lastly, hoping purple shows up, we got w to the 6th times w to the 5th. So that's going to give me w to the 6 plus 5 is 11. And so there is my very colorful final answer. Negative 50, x to the 7th, y to the 8th, w to the 11th. And there we go. So again, I think the biggest mistake that happens here is not with the adding the exponents. I think most people remember that, but I think because most of you associate the adding of the exponents here, you want to add negative 5 plus 10. But instead of doing that, remember you're multiplying, so do that step first, take care of the numbers first, and then you won't make that mistake, I don't think. Okay, so let's do one more. Coming up with a number, let's go. So here we go. Got 10x to the 5th, y to the 10th, w to the 30th, over 2x cubed, y cubed, w to the 12th power. Okay, so we're going to be dividing in this case. So let's start with the numbers. So I don't know, maybe I'll use color this way. So starting with the numbers, 10 divided by 2 is going to just be 5. So I'm just going to do that first. Again, it's an easy place to make a mistake, so I'm going to take that out of the picture. And next, I'm going to look at the x's. So x to the 5th over x to the 3rd. Well, we subtract exponents here, so 5 minus 3 is 2. So x to the... Actually, I'll write it this way. Why not? I'm here. So again, I'll make 2 rows. And after all, I've got all these sharpies. Might as well use them. Okay, so numbers and x's out of the way. Let's go to the y's. Okay, y to the 10th over y to the 3rd. We're going to subtract, so y to the 10 minus 3 is going to be y to the 7th power. And again, these are small enough that you could probably write them out. When you get to w to the 30th, you don't want to write all those out to really check it. So we're going to use this shortcut, w to the 30 minus 12. 30 minus 12 is going to be 18. So w to the 18. And there you have it. Looks like our final answer is going to be 5x squared, y to the 7th, w to the 18th. Okay, hopefully that's been a useful refresher on some of the exponent rules, and you'll feel a little more prepared for standard number 4 if you watch this before this Friday, or obviously in the future other 5 standard quizzes this term. So anyway, hope that's been good. Have a good night.